Okay guys, let us continue with lecture 10. Just now we have learned about the first properties, which is a linearity. So we're going to proceed now with second properties, which is the time shifting. So in time shifting properties, it said that if we have xt, in which if we transform is x omega, so if the xt is said to experience a shifting of time by t naught, so its respective transform with x omega multiplied with exponential of negative j omega of t naught. Okay, and for time scaling, if xt, the transformation for xt is x omega, so if I have a time scale by at, okay, so its for transform will be given by 1 over a of x omega divided by a. Okay, let's having the first example for these properties. Okay, so in these examples, we are given the first problems here, where we have a signals of yt, rectangular structure. Basically, if we based on this structure, is a rectangular signal, rectangular signal, which is said to experience a shifting by a value of half to the right, and the amplitude is scaled to 3. Okay, so let's have a look at the solution for these first examples. Okay, so okay, so this is solution for the examples here. Okay, this is the original signals, this is the rectangle of t. You can refer to the notes, we have learned this in the first chapter of signals, So we have rectangular t, which is having the amplitude of 1, and the time duration is from -½ to +½ So it can be seen that if we consider the signals to experience the following transformation, so we have scaling of amplitude by 3 and the shifting of time by half. So we are supposed to get this kind of signals here. Okay, so we can refer to the table again, the transformation table. You can refer to it. Okay, please refer to rectangular signals, where we have a signals equation of A, rectangular T over tau. So if this is the signals, the respective transform for it will be given by A tau sinc of omega tau divided by 2. Okay, so if we see that the A and tau, both of them are equals to 1, so we are supposed to get rectangular T. So Fourier transform for that will be given, or will be automatically produced to be look like this. We have a sinc of omega divided by 2, since we have A and tau equals to 1. Right, and based on what we have learned previously in linearity properties, where we have a 3 rectangle of t, so Fourier transform for that will be equals to 3 sinc omega divided by 2, because we have learned that if the time signals is multiplied by a constant, so the same things apply to its respective transform, which need to be multiplied with the same value. Okay, so that's the first case, so it's 3 rectangle of t, so respective transform will be 3 sinc of omega divided by 2. So now, if we have the next properties to be considered, which is a time shifting properties. So we have a 3 rectangular t minus half, so its Fourier transform will be 3 sinc omega divided by 2, and we need to multiply with exponential of negative j omega half. Okay, so you can refer to the properties of a time shifting that I've teach you just now. Okay, so since we have a shifting constant of half, so we need to have multiplication with exponential negative j omega of that shifting constants. Okay, so we're going to have the value, the final value for the Fourier transform is 3 sinc omega divided by 2 exponential negative j omega divided by 2. Okay, so that should be the answer for the first examples here. Okay, so I hope I make it clear to you. Okay, so let's proceed. The second examples here. So for this case, we are given a signals rectangular structure, which is also a shifting, but this time the signals is shifted half units to the left, and the amplitude is now scaled to 2. So what should be the solution for this? So let's have a look. Okay, so basically, we can write that in time domain, the signals here mathematically can be written to be look like this: 2 rectangular t plus half. Okay, so I hope that you understand how we managed to get this. So based on that, we can simply say that the Fourier transform for these signals will be 2, because we have a scale, a linear properties 2, so we have 2 here still. Okay, sinc omega divided by 2, and because we have a time shifting by half, so that's why we have multiplication with exponential of positive j omega divided by 2. Okay, is that clear on this? Yeah, so I hope that's clear on these issues of time shifting. Okay, let us proceed with the next properties. So next examples here. For these examples, we are given triangular signals. Yeah, a triangular signals where we have a triangular function which is having the amplitude of 3, and time duration is from -3 to +3. Okay, so let's have a look at the solution. These examples. Okay, so you know that for the original triangular T signals, so the signals should be look like this, where the amplitude is 1 and its time duration is from -1 to +1. So a transformation from these signals, triangular T, to these signals, yeah, where we have the scale by 3, the amplitude scale by 3, and the time duration is from -2 to +3. We can say that the time, the transformation involved mathematically should be written like this: 3 triangular T over 3. Okay, so I hope that you can work out how we managed to get this, yeah? 3 triangular T over 3. Okay, so let's have a look at the transformation table. Okay, so this is based on the table that's given the table here. So if I have A triangular T over tau, okay, you can refer to this table. Yeah, this attachment down here. Let's have a look. Okay, this is the one here. Yeah, A triangular T over tau. So the first transform is given by this. Yeah. Okay. Okay. So, right. So we see that if let's say we have a triangular T, so again we have to write A and tau to be equals to 1. So as such, triangular T transformation of that will give a sinc squared omega divided by 2. So by using the first properties, which is linearity, we have triangular 3 triangular of T. So first transform will be 3 sinc squared omega divided by 2. Okay. So the second properties to be used is the time scale. Yeah. So time scale, we have a 3 triangular T over 3. So for this, okay, we should be having Fourier transform to be written as 3, 1 divided by 1 over 3, because the constant, yeah, the time scale constant is 1 over 3. So look back, refer back to this equation just now. Okay, this is the properties of time scale. When you have xat time scale, so respective Fourier transform will be 1 over the time constant x omega over a. Okay, so for this, you can see that here the constant is 1 over 3. So we have to write 1 over the constant. Sinc squared, so we based on the previous answers, sinc squared. So this omega need to be written as omega divided by the constant. Omega divided by constant. So which is omega divided by 1 over 3. And divided by 2 furthermore. Yeah? Okay, so that's will be, yeah, we're going to have the results of 9 sin squared 3 omega divided by 2. Okay, right. Okay, yeah, so the next one, we're going to refer to these examples here, in which the triangular function that we have from the first examples is said to be shifted to the right by 3 units. Okay, so what should be its respective transform? So let's proceed the solutions now. Okay, so the solution for that, again, we are referring to the previous examples where we have from these three, triangular T of 3. Okay, so when this function, when this signals shifted by 3 units to the right, we are supposed to get this. So its respective mathematical equation to be 3 triangular T over 3 minus 3. Okay, 3 triangular T over 3 minus 3. Okay. Okay, so you can refer to these linear properties, yeah, linear properties. So we have triangular T will give us sin squared omega divided by 2. So if we have 3 triangular of T, so you are supposed to get 3 sin squared omega divided by 2. So by using the time shifting properties, you're going to have a 3 triangular T minus 3. Okay, so you're going to get 3 sin squared omega divided by 2 exponential negative j omega 3. So this is based on the time shifting properties. Yeah, so the first one just now is the linearity properties. Second one to be used is the time shifting properties. And the third one is a time scale. Okay, so for time scale, you have 3 triangular T over 3 minus 3. Okay, so we are supposed to get 3, 1 over the constant, sin omega over the constant divided by 2, exponential negative j omega over the constant times 3. Okay, so end up we're going to have the results for this will be sin squared 3 omega divided by 2, exponential negative j of 9 omega. Okay, so that should be the answer for these examples where the signals is said to be shifted by 3 units to the right. Okay, so I hope you understand the properties of time scaling and time shifting. Okay, so after this, we're going to proceed with the next properties, which is on the frequency shifting and modulation. Okay, thank you.